When comparing the means of two independent samples, small sample tests are essential. Imagine you have two groups, say, students from two different teaching methods. You want to know if one method is significantly better than the other. Here's where the t-test comes in. With small samples, we rely on the t-distribution, which accounts for the increased variability. First, calculate the means and standard deviations of both groups. Then, use the formula for the t-statistic, the difference between the means divided by the standard error of the difference. But remember, degrees of freedom matter. For two independent samples, it's the total number of observations minus 2. Once you have your t-value, compare it to the critical value from the t-table based on your chosen significance level. If your t-value exceeds the critical value, congratulations. You found a significant difference. This process not only helps in making informed decisions, but also adds a layer of rigor to your findings. So, next time you're faced with independent samples, remember the power of the t-test. Welcome back to Chandra Shekher Research Academy of Business Studies. Hello, warriors of knowledge. Today, we're exploring small sample tests, specifically how to compare the means of two independent samples. If you've been struggling with this concept, don't worry. I'll break it down step by step. Imagine you have two small samples, and by small, I mean sample sizes less than 30. You want to know if the two population means, denoted as mu1 and mu2, are significantly different. For this, we use the t-test, which is perfect for comparing two independent groups when the sample sizes are small. We begin with hypotheses. The null hypothesis, written as 80, is read as mu1 equals mu2. This assumes there's no difference between the means. The alternative hypothesis, written as h1, is read as mu1 is not equal to mu2. This suggests there is a difference between the means. The formula for the t-statistic is t equals the whole of open parenthesis, x1 bar minus x2 bar, close parenthesis divided by the square root of open parenthesis, sp squared times the whole of open parenthesis, 1 divided by n1 plus 1 divided by n2 close parenthesis close parenthesis. The pooled variance is calculated as sp squared equals the whole of open parenthesis, n1 minus 1 close parenthesis, times s1 squared plus the whole of open parenthesis, n2 minus 1 close parenthesis times s2 squared divided by n1 plus n2 minus 2. Let's clarify the terms x1 bar and x2 bar are the means of the two samples. s1 squared and s2 squared are the sample variances. n1 and n2 are the sample sizes. Let's solve an example to make this clear. Given data, sample 1, mean, or x1 bar, is 50. Variance, or s1 squared, is 16. Sample size, or n1, is 10. Sample 2, mean, or x2 bar, is 45. Variance, or s2 squared, is 25. Sample size, or n2, is 8. Step 1. Calculate pooled variance. The formula is sp squared equals the whole of open parenthesis n1 minus 1 close parenthesis times s1 squared plus the whole of open parenthesis n2 minus 1 close parenthesis times s2 squared divided by n1 plus n2 minus 2. Substituting the values, sp squared equals open parenthesis 10 minus 1 close parenthesis times 16 plus open parenthesis 8 minus 1 close parenthesis times 25 divided by 10 plus 8 minus 2. sp squared equals 144 plus 175 divided by 16 equals 19.94. Step 2. Calculate the t-statistic. The formula is t equals the whole of open parenthesis x1 bar minus x2 bar close parenthesis divided by the square root of open parenthesis sp squared times the whole of open parenthesis 1 divided by n1 plus 1 divided by n2 close parenthesis close parenthesis. Substituting the values, t equals open parenthesis 50 minus 45, close parenthesis, divided by the square root of open parenthesis, 19.94 times open parenthesis 1 divided by 10 plus 1 divided by 8 close parenthesis close parenthesis. Simplifying, t equals 5 divided by the square root of 4.4865, which equals 5 divided by 2.12, resulting in 2.36. Step 3, compare with critical value. At a significance level of 0.05 with degrees of freedom equal to 16, the critical value is approximately 2.12. Since our calculated t-value of 2.36 is greater than 2.12, we reject the null hypothesis. This means there is a significant difference between the two sample means. Congratulations! You've just mastered how to compare means for two independent samples using the t-test. Keep practicing similar problems to boost your confidence. Subscribe to Chandra Shekher Research Academy of Business Studies for more simplified and insightful lessons.